So this is the second video in our series about fractions. Last week we had a look at ordering fractions, finding equivalent fractions, and looking at fractions of amounts. And this week we're going to have a look at adding and subtracting fractions, converting between fractions and decimals, and understanding fractions as mixed numbers. And this is the aiming higher version. As a starter, see if you can work out what fraction of this circle is shaded. Pause the video and write down that fraction. It is, of course, actually an eighth, because I've split this circle into a half, a quarter, and 2/8. Fractions are often described as the part of the whole, and that can lead people to think that that's a quarter, because it's one of 4 pieces. But of course the pieces are different sizes. If they're all the same size as this one, there'd be 8 of them. Now fractions can have different meanings. So for example, last week we were looking at how, say if I was working out 3/4 of 44, I could divide it into 4 pieces, so each quarter would be 11, and then I've got 3 of them, so it would be 33. Now fractions are also used as counting numbers, so I can see here I'm counting up in fractions, and each fraction has a place on a number line. For example, the children in year 1 would count a half, 1, 1.5, 2, 2.5, 3, and so on. I've put some fractions on this number line, and you can see where in between the 2 whole numbers the fractions lie. Now we've got to be able to convert between these 2 different systems we have for working out how big a number is if it's between 0 and 1, or if it's between 2 whole numbers. Our decimal system counts up in tenths. It's therefore easy to convert between decimals and fractions if the fractions are out of 10. If they aren't though, like for example a quarter, I need to understand that what I'm doing is I'm splitting 1 into 4 pieces. And 4 0.25s? Well, of course that makes 1. That explains why a half isn't 0.2, but it's 0.5, because of course 2 0.5s make 1. See if you can work out what these fractions are as decimals. So for 3/5 I would convert it into tenths. I'd know it would be 6 tenths and 0.6. 19/20ths, if I can make it out of 100, I've obviously got to do that by multiplying the top and the bottom by 5, so that will be 95 out of 100, or 0.95. To work out an eighth, rather than converting it into 10 or out of 100, I'd probably just halve a quarter. A quarter is 0.25, half of 25 is 12.5, so half of 0.25 will be 0.125, and then for 3/8 I either need 3 0.125s, or I could add a quarter and an eighth to get me 0.375. Now it's important that you understand that fractions aren't just for numbers between 0 and 1 as we looked at before, they're actually also for numbers more than 1. Here I can see that this is one complete circle, 4 quarters, and here's a second one, so I've got 8 quarters there, and then another quarter, 9 quarters. Equally, I could say I've got 2 wholes and 1 quarter, and there's a fraction as a mixed number. It's a mix of a whole number and a fraction. Now, see if you can convert what we call the improper fraction, the fraction where the top's bigger than the bottom, into a mixed number, and see if you can convert the mixed number into an improper fraction. So for the first question, I need to understand that 3/3 is 1. So there's 3/3, there's 6/3, there's 9/3, and there's 11/3. So then I've got 3 wholes and 2/3. And 4 3/4, well, I know that 1 is 4 quarters, so 4 must be 16 quarters. And then if I add the 3 quarters, that'll leave me with 19 quarters. Now, of course, we can add mixed number fractions much in the same way as we would add any other number. If I was doing 6.8 plus 2.7, I'd probably keep the 6.8 and add 2 to it to get to 8.8, and then add the 0.7 to get to 9.5. In a similar way, when you're adding mixed number fractions, you would probably add the whole number and then add the remaining bit of the fraction. have a go at these two questions. Pause the video and see if you can add these two mixed number fractions. So for the first example, you can go 5.5 and add the 3 will get you to 8.5. I guess that's the most straightforward bit. And then I need to know that I've got to add 8.5 plus the remaining 3/4. Now, how do I do that when the fractions have different denominators? Well, you can split the 3/4 up into how many more to get to 9, that would be a half, and then how many more left of the 3/4? Well, another quarter. So that will get me to 9.25. And for the second example, a similar process. 2 4/5, add 1 makes 3 4/5. Now, if I'm going to be able to add 3 4/5 to 17/20, I probably need to make the fraction at the same denominator. So rather than having 3 4/5, I'll convert it into 20ths. 3 16/20. So now I need to do 3 16/20, add 17/20. Now for the next stage, I just need to recognise that the next whole number is when I get 20/20. So 3 16/20, how many more 20ths to get to 4? Well, it must be 4/20. Then I've got 13/20 more to add on. That will give me my final mixed number of 4 13/20. That would be a level 6 kind of question. Now, see if you can apply that understanding to subtracting fractions. Pause the video and have a go. Here I'd go through a similar process. 3.5, and first of all take off the 1, and that will give me 2.5. Then I need to do 2.5, take away 3/4, the difficult bit of the question. It will give me 1 3/4. Let's see if we can understand why. Well, there's a picture of 2.5. And that, of course, is the same as 2 2/4. If I take away 3 of those quarters, that'll leave me with 1 whole and 3/4. Now, I'm going to start the second question by changing the denominators of these fractions. So I've got 6 2/10, and I'm taking away 2 3/10. So I'm working with fractions with the same denominator. 6 2/10. Take away 2 is 4 2/10. All I've got left to do is take away the 3/10. I know if I take 2/10 away, that will leave me with 4. So I've got to do 4, take away 1/10. That'll leave me with 3 9/10. 1/10 less than 10/10, a whole. Well done for getting this far. Now, if you need a real challenge and you're doing really well, have a go at this question. This will get you all thinking. So I guess the essence of the question is, how many 2/3 are there in 7? Now, without actually having to count them, I should recognise here that in 7 mangoes, a 3/3 is in 1, so in 7 there must be 21/3. Now, if each guest has 2/3, then 10 guests would have 20/3, and then there would be 1/3 left over. That, of course, leads to my answer, which is 10 guests. Now, well done if you've managed to get this far, and a massive well done if you've managed to answer that question. Remember to fill in all your workings in your maths homework video and get it signed off. We'll see you in class next week.